is, I don't know, culmination of multiple things. Okay, this is solving systems of equations again. Now, the difference is in the past we've solved systems of linear equations, where it is two lines. These are systems of linear quadratic equations. So where one equation is a line and the other equation is what's a quadratic? Parabola. Or what's the main other graph we've talked about this year, right? So we're going to use some graphing techniques. We're going to use some substitution techniques because elimination doesn't really work here. And then we're also going to look at inequalities. So when we throw in the less than, greater than. Okay? So let's start with example A. Solve each of the following systems by graphing. So we need to go through these and kind of remember our graphing pieces. Okay? We're going to start with y equals x squared plus 6x plus 9. Thoughts on how to go about graphing this?
We gotta get x squared mixed up. Probably maybe square root or everything else.
No, because I would still have x's there. But this equation also isn't equal to 0. And my suggestion is going to be think about how have we graphed quadratics earlier in this chapter. Now, unfortunately, that means going back to like 2.1, 2.2. I think we've done all of our graphing in 2.1 and 2.2. So we're going back that far. Probably more to 2.2 than 2.1 is my guess. I'm trying to remember exactly. Yeah, because 2.1 is vertex form. This isn't vertex form. This is standard form. Standard form we graphed in 2.2, and there was a formula to get us started.
Is it the x equals x? Yeah, it's ax squared plus bx plus.
Well, this is in the ax squared plus bx plus c form.
So then you find your axis of symmetry. X equals negative b over 2a.
Okay, so axis of symmetry. X equals negative b over 2a. When we have standard form, this is our go-to graphing method. So negative b is going to be what? Negative 6 over 2 times a. So negative 6 divided by 2 is negative 3. So our axis of symmetry is x equals negative 3. After you do the axis of symmetry, what's next? We need the vertex. What do you know about your vertex? Negative 3 something. How do we find something?
Plug x in.
Plug the negative 3 in for x. So y equals negative 3 squared plus 6 times negative 3 plus 9. No. We are graphing the top equation right now. The bottom equation will be a whole separate graph. So we have to use the equation we're trying to graph. Negative 3 squared is 9. 6 times negative 3, negative 18 plus 9. 9 minus 18 plus 9.
0.
0. Got some math mistakes here?
It's too early.
Okay, so vertex is negative 3, 0. Now, with that in mind, folks, what was the other piece of information? Well, there's two ways we can graph from here. What's the other piece of information we used at the time? Your y-intercept. And my y-intercept is my c value, yes? What is my c value? 9. So we can use a y-intercept of 9. The other thing I will talk about here, what type of x squared is out front here? It's a 1x squared, right?
Yep.
What's a graph look like that is 1x squared? From the vertex, where do you go? Over 1, up 1, and over 2, up 4. Can you use that since it's 1x squared? Yes. You can't use it if it's some other type of x squared, but you can use it if it's 1x squared. So you can also use that idea. Where do I want to put this? Try and leave room because we still need to talk about the other one. But you can also use the idea of 0, 0, 1, 1, and 2, 4. Okay, so let's graph this while we have all this. X equals -3. Says I have an axis of symmetry that is 3 left, yes? Now, I'm not going to draw in that axis of symmetry because I don't need all the extra confusion. But, or maybe I'll draw it in and erase it. I don't know. The vertex is at -3, 0. Officially, the y-intercept is at 9. If you're just looking at y-intercept, the y-intercept is at 9. If we have this y-intercept at 9 that is how many to the right? 3 to the right of the vertex, then we need an equivalent point, 3 to the left, or count over 6. Okay? Now, you can draw your vertex just like this if you want, or your parabola just like this. Although I would encourage us to think about what's the basic form of a parabola. Here's my vertex, 0, 0, over 1, up 1, over 1, up 1, and over 2, up 4, over 2, up 4. Keep in mind, we're solving a system of equations here. So it's going to be important how and where we graph these. And notice that next set of points that we did is over 3, up 9. We already did that, but it ends up being over 3, up 9. Okay, so I'm going to attempt to connect my points here. Okay. And I'm going to find a different color.
I think Savas usually just put the vertex and the y-intercept.
Yeah. But then Savas will automatically, you put the vertex and one extra point, then Savas automatically perfectly forms it. On paper, we can't do that. Okay. The other thing we need to graph is y equals x plus 3. What do you know about y equals x plus 3? There's no x squared, so what's that mean?
It's just that you don't have it in
Lines.
It's a line.
Yep.
And I heard y equals mx plus b, yes? So what do we know?
X is 1, or M is 1.
Y-intercept is 3, m is 1, which means our slope is 1. So, y-intercept of 3, we go up 3. What do we do for a slope of 1?
Over 1, up 1.
Yeah. Rise 1, run 1. So, rise 1, run 1, up 1, over 1. Where do I really need to go, though?
Down.
Reverse it. Down 1, 1. Down 1, left 1. Down 1, left 1. Down 1, left 1. However many times you want to go. Okay? That forms my line. Okay. What's my answer to this problem?
-2, 1.
3.
Are there two answers?
Yes.
Very close and overlap, very close, aren't they? But we've got 2 points. We're looking at these 2 points right here where they both overlapped. So left 2, up 1 is -2, 1. Left 3, up or down 0 is -3, 0. So on Savas, you would probably put ordered pair in parentheses, comma, and then next ordered pair in parentheses would be my guess of what they would expect. Are we often going to have two solutions here?
Yes.
Often. Okay, will we always have two solutions?
Yeah.
No. You could have no solutions, you could have one solution. It'll just depend on the graph. Okay, questions on that one?
So we're basically just doing all the stuff we've already learned, but graphing.
And putting it all together. We already know how to solve by graphing. You know to graph the two and look for where they meet. You already know how to graph lines. You're supposed to know how to graph quadratics. It's a little rusty, but we know. So it's just putting it all together. Okay, let's try B. Okay, let's start with y equals negative x squared plus 2x plus 5. Is it warm in here, or am I just warm? I hate to turn down the temperature because that could make me freeze later today, but
Go ahead and chat.
I can't. Okay, thoughts on graphing y equals negative x squared plus 2x plus 5?
Get the x.
Okay, it's a parabola because it's x squared. It's not in vertex form where I already know the vertex, so we're going to go for a axis of symmetry. Axis of symmetry formula, it's on that blue paper, right? Negative b over 2a. So negative of 2 over 2 times a, so 2 times negative 1. Negative 2 divided by negative 2 is 1. Axis of symmetry, x equals 1. After the axis, we need the vertex. My vertex is 1 comma something. We're going to take the 1 and plug it into the quadratic, right? So it's the negative of 1 squared plus 2 times 1 plus 5. What is the negative of 1 squared? Negative 1. Okay, so here's the deal, guys. This equation says to square 1 and then do the opposite of it when it has that negative out front. So we're going to square 1, which gives us 1, and the opposite of 1 is negative 1. 2 times 1 is 2 plus 5. And that's really supposed to be y equals, and I kind of dropped that off for whatever reason. Negative 1 plus 2 plus 5 is 6. So, a vertex of 1, 6. Y-intercept of?
5.
Yeah, my C value is 5. So y-intercept of 5. Now, that might give me enough information. You might need a little bit more than that. I don't know. We haven't graphed this yet, right? Can we use the basic form of a parabola? What is our A value? It's negative 1. So it's still a 1, yes? What's the negative mean?
Go down.
It's going to go upside down. But then with that in mind, we can still use the idea of from the vertex, you go over 1, then down 1, and over 2, down 4. So you can still use that 0, 0, 1, 1, 2, 4 idea. Okay? Not those specific, we're not graphing those specific numbers. That's just in relation to the vertex. Okay. Axis of symmetry, x equals 1. That's my centering point, my centering line. Vertex is
1, 6.
1, 6. So right 1 up 6. Y-intercept is 5. That's not really enough. Well, and if my y-intercept is, what is that? That's 1 to the left of the vertex, so we also need 1 to the right. Again, depends where our line goes, whether that's enough points or not, right? So from the vertex, I already have the points that are over 1, down 1. I can also put points that are good, over 2, down 4. And that's over 2, down 4 from the vertex. If you really want to get fancy, you could do another set of points. That next set of points would be over 3, what's 3 squared? 9, so down 9. I know enough to know that we have enough information here, so you wouldn't have to. I mean, I guess if you want to get technical, we have a set of points right there, you know. Again, extra information. Okay, there's our parabola. What do we know about y equals 2x plus 5? Okay, so y equals mx plus b. 5 is our y-intercept, and 2 is our slope. So that means that slope is going to be 2 over 1. So y-intercept of 5. Okay. And rise 2, run 1. Rise 2, run 1. And we can
Low 2.
down 2, over 1. Down 2, over 1. It does only have one point of intersection.
I thought so.
Now, and what's the tricky part about this one? It kind of looks like my first point that was down to left 1, it kind of looks like that lands on my graph, right? However, is that an actual point of my graph? No. Okay. So this does only have 1 point. Okay. And what is that answer? 0, 5. Okay. So you have to be careful there. This, I don't know what we remember from geometry, but this line would be tangent to the parabola. I think that's a geometry word for you. So the line is tangent because it touches the parabola once. Does it touch and go? Okay. There's your graphing. All the stuff you know is just putting it all together. Let's solve now using substitution. And I know, personally for me, I usually tend to use more elimination, and I feel like you guys usually prefer more elimination. However, elimination does not work when you have a quadratic and a linear. Okay? It just doesn't work. So, well, I guess it does. It's just you're always eliminating the y's. So, with this substitution, I have y equals negative 3x squared plus x plus 4, and y equals 4x minus 2. How does substitution work?
Well, we gotta plug in something for something else.
Okay. Plug in something for something else.
So what I would do is subtract over the x. And then divide it all by 4.
You're making this way too difficult.
Oh.
You're taking a try at it,
I
though.
didn't want you to feel left down up there.
Okay, thank you. Substitution, guys. If you remember substitution, we usually picked one equation and solved it for something, right? And I'm trying to think, did we say it could be x equals or y equals Yeah, we said it could be x equals or y equals. Take an equation, make it x equals or y equals, and then whatever that is, you plug it into the other equation.
So could you just do like 4x minus 2 is equal to
Essentially, both of these equations are already y equals, aren't they? And if I recall, I don't know, they're pretty much going to be that way. So, and it doesn't really matter which way you look at this, but the idea that since they're both y equals, we take one equation and plug it into the other one. So, for instance, y equals negative 3x squared plus x plus 4. I can take that and plug it into y in my other equation. Basically, if they're both y equals, you end up making these equations equal to each other. That's what's going to happen, is these equations end up being equal to each other. So I end up with negative 3x squared plus x plus 4 equal to 4x minus 2. Okay? Okay, now we've got to solve.
x?
Do what?
Subtract the x.
Okay, we can. What's our goal here? Because there's multiple different options I could go, but all have to have the same goal.
X equals number.
Well, if it was just x's and numbers,
3x.
I would say yes. But what's the catch? We also have an x squared. What is our trick for solving x squared equations most of the time? Make the equation equal to 0. Okay? Because I have x squareds, x's, and constants, I'm going to make my equation equal to 0. And then we're going to see what happens. Now, you can make this equal to 0 any way you want. I think I'm actually going to leave it my negative x squared term for the moment. I'll deal with it. So if I'm going to make it equal to 0, I'm going to subtract 4x and add 2. And if I subtract 4x and add 2 on the right, I'm also going to subtract 4x and add 2 on the left. So then I still have negative 3x squared. X minus 4x is negative 3x plus 4 plus 2 plus 6 equals 0. What do all of those have in common? Even better than 3. Negative 3? Because one of my methods that we can hopefully be able to use, I prefer to have a positive x squared. Now, because this equation is equal to 0, I can just divide by negative 3. Okay? If it was just an expression, we have to factor it out. But I can totally divide everything by negative 3 because there's a left and a right to divide by negative 3. So, when I divide by negative 3, this becomes x squared plus x minus 2 equals 0. What are my solving options here?
2 parentheses.
Okay, can it factor?
Um,
We're hoping it can factor, right? If this is quadratic formula, that's a really nasty trick if we have to then also plug it back in to find our y values later. So quadratic or factoring should be a go-to here. Which is why I wanted to divide by negative 3, because I wanted to get rid of that negative as well. X squared, we know, breaks into x and x. I need my numbers to multiply to be negative 2 and add to be 1.
So 1 and 2.
Positive 2 minus 1. Because 1 times 2 is my only option for multiplying by 2. If it multiplies to be negative, I need a positive and negative. If it adds to be positive 1, I need a bigger positive number. Okay, what do we do here?
Set up both equal.
Okay, we're going to send both equal to 0. Must have written too big. I don't know. Okay. So I guess I'll bring it right up here. X minus 1 equals 0 and x plus 2 equals 0. What do we know? X equals 1. X equals negative 2. Am I done?
Sadly,
No. We just did all that work, found our x's. Now, the hard work is done. We still need to find our y's. Because what kind of answers did we have on the graphs? We had ordered pairs, right? We need ordered pairs here. So what I know right now, x equals 1. One of my answers is going to be 1, comma, something. My other answer is going to be negative 2, comma, something. I know my x's. I need to find my y's. How are we finding our y's?
Plug 1 into the top equation, 1 into the bottom equation.
That
or
sounds
just plug the one.
that sounds
into
too
the bottom
difficult.
and then plug the bottom.
How about we can plug them both into whichever equation we please.
You plug
Which, if I please, I'm going to plug them both into the bottom equation here. Okay? And it doesn't matter. If you want to plug them both into the top equation, can you do that? Yeah. Can Patrick plug one into each? Sure. It doesn't matter what equation you plug them into, is my point. So my recommendation, make life easy on yourself, right? So y equals 4x minus 2. So when we plug in 1,
you get 2.
4 times 1 minus 2 is 4 minus 2, and we have 2. When we plug in negative 2, 4 times negative 2, minus 2. 4 times negative 2 is negative 8. Negative 8 minus 2 is negative 10.
So how do you know which equation?
How do I know what?
Like, how do you know the one goes with? One goes with two. Like, how do you?
Because right here, I plugged in 1 for x. So when I plug in 1, I got out 2.
Okay, I just have to do it. Right.
Okay? Over here, I plugged in negative 2. When I plugged in negative 2, I got out negative 10. Does that make sense?
Yes.
Okay. It wasn't magic, I promise you. And that was these values. I did go up here and plug them in up there. Okay. So, again, all skills we kind of know, right? Putting it together into one problem. So let's try B. My goal is to solve. I have a system of equations. They're both y equals, so what can I do? Set them equal to each other. Okay? Doesn't really matter which way. You're just going to end up setting them equal to each other. So 2x squared minus 6x minus 8 equals 2x minus 16. Okay? I see an x squared in there along with x's. So I want to make my equation, because I see x squared, I want to make my equation equal to 0. So subtract 2x, add 16. Subtract 2x and add 16 to their appropriate terms. 2x squared minus 6x minus 2x minus 8x minus 8 plus 16 plus 8 equals 0.
Divided off.
Yeah. And you could go product of AC or slip and slide right here, but why? So everybody divides by 2, so let's make that happen. So x squared minus 4x plus 4 equals 0. What do we know? X squared breaks into x and x. Multiplying to be 4 and adding to be negative 4. So if it multiplies 4, adds to be 4, it's a 2-2 combo. In this case, since it adds to be negative, they are negative 2's. So x minus 2 times x minus 2. What do we know? Yeah, it's going to be the same answer. So really you just have to set x minus 2 equal to 0. And we're going to get x equals 2. Is it okay that we have just one x?
Yep.
Yeah, we had a graph that had just one intersect point, right? And that is possible. Okay, am I done? No. What do we know? Okay. We know that my answer is going to be 2 comma something. Plug it into whichever equation makes you happier. Personally, the bottom equation makes me happier. So y equals 2x, so 2 times 2 minus 16. 2 times 2 is 4. 4 minus 16 is negative 12. And you have one solution there. So that is possible. Okay.
Yeah, it's been great.
Yes.
Start this other.
There's not enough time for that.
No. What are we gonna do tomorrow? We don't have anything to do.
I'm gonna get so useful.
On the back. What's going to be different on the back?
There's inequality.
There's inequalities.
Yep.
Inequalities means we're going to be shading, yes? Okay. When we talk about shading, we're looking for where does the shading
Overlap.
overlap, right? So we want to know where that shading overlaps. And that's what we're going to be graphing here. I don't know.
Yeah, there's only like 1 minute. I would put that away.
Oh.
Now, as we look at y greater than, gosh darn it, y greater than x squared minus 4. Keep in mind to start with, we need to graph y equals x squared minus 4. What do you know about y equals x squared minus 4?
4 first square.
It is.
So we just take
No. I guess we could. I mean, y equals x squared minus 4. What's the shape of this graph?
Parabola.
Parabola. There's no x value. What's that minus 4 do?
It becomes the X.
If you take y equals x squared, which is parabola, and you tag on a minus 4.
Oh wait. I don't know.
Yeah. Wait.
Yeah, moves it over.
Intercept. X-intercept.
Stretches forth.
See, we can't even hear the
I don't know. Do you know?
I know.
Well,
You guys should know.
bet
Well,
you
why
don't.
don't you tell us? I don't think
I bet
we
you don't
do
know.
that.
You don't know. You don't know. You know what you're asking us.
You tell me, what does that minus 4 do to this graph?
It makes
Moves
it
it right
minus
forward.
4.
Left, up, down, forward.
Well, you've officially said all 4 directions, I think, now.
Up, down, left, or right? Oh, that's what he said. That's what he said. You intercept down. I said point intercept.
That's what I said.
Oh, me too.
See,
Okay.
what I said, right?
Okay. So the idea here, guys, and a couple of different ways you can think about it. But if we just think about like y equals x squared, Remember our values of 0, 0, 1, 1, and 2, 4? Take these values and move them down 4. Now, could you do axis of symmetry on this if you wanted to? You can. But to me, if I can identify that as just an x squared graph that then moves down 4, life is a little easier. Okay? So if I take this x squared graph, my vertex is normally 0, 0, moves down 4. Where is the rest of my graph? From 0, 0, I go over 1, up 1.
Over 2, up 4.
Over 2, up 4.
Over 3, up.
You really want to? Over 3, up 9. I'm not saying you have to do that. Now, before you connect your parabola, what question do you have to ask yourself?
Minimum.
Is x squared minus 4 greater than or less than y?
What kind of parabola do I draw? What kind of line do I connect these with?
A dotted.
Ah, a dotted line.
Oh.
Why is it dotted?
Because there's no line under it.
It's greater than only, so that's going to be a dotted line. And where am I going to shade?
Everything in between.
Your options are above or below? Because this is what type of symbol? Is that a less than or greater than sign?
Greater.
It's a greater than sign, so greater than sign says we're going to shade above. I should have asked you, where is above? I just did it for you.
The sky.
Above is, so above the graph is going to actually end up being inside the parabola. Okay, we'll do the other half tomorrow.
That's all.
Huh?
We didn't even get it.
Well, I kind of thought you guys would pick up the x squared minus 4 a little bit better. Graph it a
But
little bit
same
better.
y-intercept and you